So welcome to our passage number 5, and here I am with you, sir. This is going to be the 5th passage of this particular series, where my goal is to ensure that you move ahead towards sensational accuracy rates by thinking like me. In case you're new to our channel, I'd really appreciate that you subscribe and press the bell icon so that whenever I upload a video for you, you are right there to know of it. And in case you and I have not met earlier, my name is Vikrant and I'm a 100% percentiler in the CLAT exam, and I think I've coached thousands of students over the course of last 24 years. So you are in really safe hands when you work with me. So on iQuanta's channel, I am your personal coach for all things related to English, communication and the mental aspects of preparation. The process is very simple. In case you've attended the earlier sessions, you know that you are going to work on a passage and answer the questions by yourself. Then we will go ahead and work on it together. So let's go ahead and dive into it straight away. Here is the first slide. Please pause the video here, read this paragraph and then move on. Then play and move on to the next one. Next, pause. Next, pause and read. Okay, so it's next, pause and read. Next, please pause and read. Next, pause and read. And that is the last paragraph of the passage. Here are the questions, starting with question number 1. So pause, answer the question, and then I'll take you over to the next one. Next, so please pause and answer. Next, pause and answer. Next. So that was the last question based on the passage. So let's go ahead and work on it together. Now, if you look at the last 5-6 years, you'll see that there are some areas which get asked quite frequently. One of those areas happens to be biology, especially zoology. Then we've seen a fair bit of passages from anthropology. We've seen passages that are based on sociology, science and technology. Some of the old favorites like philosophy and political theory are still around. So they expect us to know this. So let's read this together. Octopuses are misfits in their own extended families. So they somehow, the sentence itself tells us that they're somehow different from others like them. They belong to the mollusca class Cephalopoda. So within biology you have these classifications. So there is this large category called mollusca. Mollusca basically talks about those animals which are they don't have a bony structure. In fact, you know this root word moll, this actually means soft. So you've seen animals like snails, clams, octopus, they're very soft and squishy. We get a lot of words from this. When somebody is upset, agitated, you can mollify them. And during the winters, when the skin goes dry, at times feels brittle, you apply these emollients on them to make them soft again, to get that softness out once again. So mollusks are like snails, clams, octopus. And then, of course, just get used to this word called cephalopoda, which is just another classification category. But they do not look like their cousins at all. So the octopus, they have other people like snails, clams, they don't look like them. Other mollusks include sea snails, sea slugs, bivalves. Bivalves have, their shell is divided into 2 distinct parts. Most are shelled invertebrates. So invertebrates are those animals that don't have a backbone. But not just a backbone, they don't have a skeleton system. There are quite a few of them. You've seen spiders, etc. and all. So most are shelled invertebrates with a dorsal foot. So basically they happen to have a muscular appendage of their body that allows them to move. So you've seen snail would contract its muscles and then slide forward, then contract, then slide forward. So that thing can be called a foot, if you may. So cephalopods are all arms. Octopus are cephalopods. They are all arms. They don't have a dorsal foot. They don't have a shell. They can be as tiny as 1 centimeter and as large as 30 feet. Some of them have brains the size of a walnut. Now to you and me, that's pretty small, but then for an invertebrate, that's quite large. Then the next paragraph says, it makes sense for these mollusks to have added protection in the form of a higher cognition. So in a way, this sentence links the paragraph with the previous one. It says it makes sense for them to have superior brain power in order to protect themselves. Why? They don't have a shell covering them. So, you know, those mollusks that have a shell, they can always, or clams. Remember, clams can always shut themselves and protect themselves, right? But octopus, well, an octopus does not have any shell. And pretty much everything feeds on cephalopods. So all the other creatures won't mind eating them, including humans. So there are some parts of the world, particularly the Mediterranean, where they are thought of as a delicacy. But how did cephalopods manage to secure their own invisibility cloak? So how is it that they are able to remain invisible from their predators? So cephalopods fire from multiple cylinders to achieve this. Achieve what? To remain invisible in varying degrees from species to species. So there are 4 main catalysts. So when you say multiple cylinders, you are in a way saying that there are different strategies that are employed by these creatures. And there are 4 main things that they use. So something called chromatophores, iridophores, papillae and leucophores. So let's dive into the next paragraph. Now this paragraph focuses on chromatophores. So chromatophores are organs on their bodies that contain pigment sacs. So a sac is a small pouch and pigment basically means color. So chromatophores are tiny pouches full of color. Which all colors? They happen to have red, yellow and brown pigment granules. These sacs have a network of radial muscles, meaning muscles arranged in a circle radiating outwards. Okay, so something like this. So this kind of arrangement for the muscles. These are connected to the brain by a nerve. When the cephalopod wants to change color, the brain carries an electric impulse through the nerve to the muscles that expand outwards. So these muscles will expand outwards. So there is a sac, right? It's tightly closed. And then these radial muscles are pulled outwards. So the sac opens up and that displays the color on the skin. Now why these 3 colors, red, yellow and brown? Because these are the colors the light reflects at the depths they live in. The rest is absorbed before it reaches those depths. So basically the part of the sea that they live in, red, yellow and brown are the only 3 colors that you get to see, because all the other colors are already absorbed by all those layers up top. Yeah. Fancy that. Okay, then, well, what about other colors? So how do you come up with the other colors? Cue the iridophores. So that is a signal for iridophores to be brought into the discussion. Think of a second level of skin that has thin stacks of cells. These can reflect light back at different wavelengths. It is using the same properties that we have seen in hologram stickers or rainbows on puddles of oil. You move your head and you see a different color. So you remember all those holograms? You remember this these multiple colors that you see on the slick layer of oil, right? That property is actually called iridescence. Iridescent basically means showing many bright colors that change with movement. So for example, her latest fashion collection features shimmering iridescent materials. So they don't change their colors, but when you move, the colors appears to change. So you move your head and you see a different color. The sticker isn't doing anything but reflecting light. It is your movement that is changing the appearance of the color. This property of holograms, oil and other such surfaces is called iridescence. So chromatophores, and then you have this thingy called iridophores. And then you have papillae, are sections of the skin that can be deformed to make a texture bumpy. So see, I have a smooth texture, you have a smooth texture, but then this paragraph says even humans possess them, goosebumps. So there are times when you're very excited or something touches you deeply and you got this, these tiny little pores, they make your skin rough. But we cannot use them in the manner that cephalopods can. We cannot really consciously control them or command them. So for instance, the use of these cells is how an octopus can wrap itself over a rock and appear jagged. It can appear rough like a rock. Or how a squid or cuttlefish, which are other sea creatures, they can imitate the look of a coral reef by growing miniature towers on its skin. It actually matches the texture of the substrate it chooses. So substrate is a surface on which an organism, such as a plant, a fungus, an animal, lives. So basically, they can make their skin textured just like the surface that they are on. So they do that with the help of papillae. Finally, the leucophores. According to a paper published in Nature, notice the capital N, it is the name of a very prestigious science magazine. Cuttlefish and octopuses possess an additional type of reflector cell called a leucophore. They are cells that scatter full spectrum light so that they appear white in a similar way that a polar bear's fur appears white. Leucophores will also reflect any filtered light shown on them. If the water appears blue at a certain depth, the octopuses and cuttlefish can appear blue. If the water appears green, they appear green, and so on and so forth. So basically, they scatter the full spectrum of the light that is put on them, but then they can appear white. So white here basically would mean that they just resemble the background in their case. Okay, so now the questions. So question number 1, all of the following are reasons for octopuses being misfits except that they. Now, if you look at the passage, I think it's the first paragraph which should stand out in your mind. So notice, this is the one that talks about octopuses being a misfit. Why? Others have a shell, others have a foot, others have a brain which is smaller, right? These are the kind of differences that we have talked about, right? So if I go ahead and now look at all of these different answer choices, which one should we go ahead and choose? So let's look at A. They have several arms. Is this a reason for them being a misfit? Okay, let's look at B. They are consumed by humans and other animals. Is that? So let us go ahead and look at the first question. All of the following are reasons for octopuses being misfits except that they. So, except questions are in a way odd one out questions. So you would notice that 3 of these are cited in the passage as reasons for octopuses being misfits within their extended family, and one of them is not going to be the reason. Now, where were they mentioned as misfits? If you have managed to generate a mental overview of the passage, then I think you'd be very easily able to refer to the first paragraph. And what all things have we been given? So cephalopods, that's octopuses, are all arms, so that's one difference. Then the other difference is, so they don't have shells. Most are shelled invertebrates with a dorsal foot. Cephalopods are all arms, so no shell, no dorsal foot, all arms. Then their size, the variance in their size, and then their intelligence, which is significantly higher than the others in their category. So which all things, so these are the things that make them misfit in their extended family. So they have several arms, yes, that makes them a misfit. We are looking for except, so this gets ruled out. They are consumed by humans and other animals. Yes, they are, but is that given as a reason for there being a misfit? Nope. So let's keep this in running. They do not possess an outer protective shell. Yes, that's something that makes them a misfit. So let's eliminate. They exhibit higher intelligence than other mollusks. Yes. Look at this last part. The brain size. So even this gets ruled out, and as a result we can confidently choose B as our answer. So let's dive into the next one. Question number 2. Based on the passage, we can infer that all of the following statements, if true, would weaken the camouflaging adeptness of cephalopods except. So first up, if true means whatever is given, let's accept it as true. Now if it is true, it would weaken the camouflaging adeptness. When you're adept at something, you're quite skilled at something. So 3 of these will tell us that, hey, octopuses are not that great at camouflaging because of these reasons, and one of them will either strengthen it or will be irrelevant, and that is the one that we'd go ahead and choose as our answer. So let me take you to a part of the passage. Here, check this. What do we know about chromatophores? They contain pigments which are red, yellow and brown. Then there are radial muscles that are connected by a nerve. The electric impulse brings in, expands it, and that's how they change their color. So now let's read A. The hydrostatic pressure, that is the pressure caused by the water at the depths at which cephalopods, that is octopuses, reside, renders radial muscle movements difficult. Now if you look at it, the passage tells us that radial muscles expand outwards, pulling open the sacs. But if the water pressure will make the movement of radial muscle difficult, will it make octopuses skilled at changing colors, or will it prevent them from changing colors? This is something that is going to prevent them from changing colors. So A weakens, so let's mark it with a W. B, the temperature of water at the depths at which cephalopods reside renders the transmission of neural signals difficult. So once again, you notice this strategy that we are talking about here in the passage, it requires the transmission from a nerve. Now this option says that this transmission is going to be difficult. So again, their adeptness will go down. So this also weakens. C, light reflects the colors red, green and yellow at the depths at which cephalopods reside. But then, hey, look at the passage. It says that the 3 colors that are reflected are red, yellow and brown. That's why they have these 3 color sacs. But if instead of red, yellow and brown, you have red, green and yellow, if no brown, then it can make them less effective. They are missing out on a color which is important. So this will also weaken. D, the number of chromatophores in cephalopods is half the number of iridophores and leucophores. This is irrelevant, right? We do not know how these numbers and their relative numbers are important for an octopus to go ahead and hide himself or camouflage itself successfully. So this is irrelevant to the argument. That neither weakens nor strengthens. So A, B and C very clearly weaken. So they get eliminated. D is irrelevant. So let's go ahead and mark that as our answer. And with that, here is question number 3. Based on the passage, it can be inferred that camouflaging techniques in an octopus are most dissimilar to those in. Now this is more of a specific detail question, but then it required overview. So let's look at question number 3. Based on the passage, it can be inferred that camouflaging techniques in an octopus are most dissimilar to those in. So this is essentially going to be a specific detail question, but it requires overview because you need to tap into different parts. So you notice all of these, or at least some of these different creatures are mentioned within this particular passage, and in some cases their camouflaging techniques has been termed similar to the camouflaging technique of an octopus. So here are some of these relevant parts. So in the fourth paragraph, you'd notice that they have been compared to a squid or a cuttlefish when it comes to their action of their papillae. Similarly, in the fifth paragraph, you once again see the cuttlefish, and along with that you also see that's how a polar bear functions. So their camouflaging technique seems to be similar to a squid, a cuttlefish, and a polar bear in some respects. However, a sea snail, so polar bear, squid, cuttlefish, they are mentioned. A sea snail is mentioned only in the first paragraph in the sense that they are different from sea snails. Octopuses are different from sea snails, they're cousins. They are not mentioned with respect to camouflaging, similarity of camouflaging technique at all, and that is why our answer to question number 3 must be option B. And with that, let's dive into the last question. Which one of the following statements is not true about the camouflaging ability of cephalopods? Okay, so cephalopods can take on the color of their predator. We don't know. We know that they can take on the texture of their substrate and the color of their surroundings. They can take on the color of their predator is something that cannot be determined from the passage. Let's look at B. Cephalopods can blend into the color of their surroundings. True. Cephalopods can change their color. True. Cephalopods can change their texture. True. Remember, these are the things which taken together are called their invisibility cloak in the passage. So we are looking for something which is not true. B, C and D are true. A is not true, and therefore our answer to this should be option A. And that is where you and I will stop. And do remember that it is all about conquering ourselves. If you go on to conquer yourself, absolutely nothing can stop you. Just a reminder once again. So that's where we'll stop in this particular session. I'll see you in the next one, where we'll dive into one more passage and work on it together. Until then, stay safe, stay focused, and stay in touch. If you need to know anything, ask us anything, you can of course drop a comment below, and don't forget to like the video before you leave and do subscribe. Take care. See you in the next one.